Hello. In this lecture, we will find out the energy of the electron in the orbit. In the last lecture, we will derive the expression for the radius of the orbit, and the expression is n square h square 4 pi square m k z e square, where k is the electrostatic force constant and its value is 1 upon 4 pi epsilon naught, or it is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. It means the radii of the orbit depends on these factors. It is the value of all the constant, and it shows that the orbits are not equally spaced. Now, the velocity of the electron is obtained by this relation, and it shows that the velocity is inversely proportional to the orbital quantum number. For the hydrogen atom, for n equals to 1, the velocity is observed to be 2.2 into 10 to the power 6 meter per second. Moreover, it is also observed that the orbital velocity of the electron in outer orbits is smaller. Larger the orbit number, smaller is the velocity. Now let us find out the energy of the electron in the nth orbit. As you know very well that the kinetic energy of the electron equals to half m v square. Now put the value of v. So it is equal to half m 4 pi square k square z square e to the power 4 upon n square h square is the kinetic energy, and the potential energy is equal to the k q1 q2 upon r. We know it from the electrostatics. K is the electrostatic constant, so I'm taking it here as k for the simplicity. Q1 is the charge of electron, it is negative. Q2 is the charge of the nucleus. If Z is the atomic number, Z is the charge of the nucleus. Now put the value of R. So it is n square h square 4 pi square m k z e square. Now when we compare these two expressions, it is observed that the potential energy is 2 times of the kinetic energy. And when we have to find out the total energy, then the total energy is the sum of the kinetic energy and the potential energy. Kinetic energy is 1 by 2 m 4 pi square k square z square e to the power 4 upon n square h square minus k z minus k square z square e to the power 4 pi square m upon n square h square. So the expression is equal to minus 1 by 2 4 pi square m k square z square e to the power 4 upon n square h square, which is equal to the kinetic energy of this. So we can see that the relation is total energy of the electron is equal to the negative of the kinetic energy of the electron, or we can say it is half of the potential energy of the electron, and this is equal to 4 pi square m k square z square e to the power 4 upon 2n square h square. So this can be 2. When we put the values of the constants, it is observed to be 2.18 into 10 to the power minus 18 upon n square into z square joules. As you know, 1 electron volt equals to 1.6 into 10 to the power minus 19 joule. So it is equal to minus 13.6 z square upon n square electron volt. So the energy of the electron in the first orbit is equal to, in the first orbit of the hydrogen atom. For the hydrogen atom, the value of Z is 1. And in the first orbit, the value of N is also equal to 1. So the energy is minus 13.6 electron. In the second orbit, the value of N is 2. So minus 13.6 upon 4 equals to minus 3.4 electron volt is the energy of the electron in the second orbit of the hydrogen atom. In the third orbit of the hydrogen atom, the energy is minus 13.6 upon square of 3, that is 9, which is equal to 1.51 electron. And so on. In the nth orbit, E is approximately equal to 0. It is important to note that all these relations have been derived assuming that the electron moves in circular orbits. Thank you and have a nice day.